Greetings and hello everyone. Today we're going to be working with solving with formulas. So let's take a look at our first example. So example 1, I want to solve 5a minus 2b equals 15. I'm going to solve this for a. So this is what I want to get by itself. I want to get a on one side equaling whatever I have. So I'm going to start undoing whatever's happening to a. First, a is being multiplied by 5, and then it's being subtracted by 2b. So I'm going to start with adding 2b to both sides. Now I can't add 2b to 15 because this is a unit term, and this is a variable term. So that's why I kind of put it off to the side. So that leaves me with, on the left, 5a. And on the right, I have 15 plus 2b. As I said, this is a unit term and this is a variable term, so they're not like terms, so I cannot put them together. My next step is I want to undo the multiplication. So when I undo the multiplication, I'm going to divide by 5 on both sides. So on the left, 5 divided by 5 is just 1a. And on the right, there's two ways I could do this. I can leave this as 15 plus 2b divided by 5, and that could be my final answer. The other way I could do this is I can divide both terms by 5. What does that look like? Well, that looks like this. The first term, 15, is going to be divided by 5. And the second term, 2, is also going to be divided by 5. So 15 divided by 5 is 3. 2 divided by 5 is just 2/5, so I'm just going to leave it as 2/5 b. So you can either have it like we have here, or you can have it like we have here. Both of these are equivalent answers. They mean the same thing, just a different look. All right, let's take a look at the next example. So example 2. I want to solve 4p minus 7r equals pq plus 16. And I'm going to solve that for p. Well, I start off with noticing I have a p on the left and I have a p on the right. I need to get them both on one side. But before I do that, I need to get rid of this 7r. So I'm going to undo subtraction with addition. I'm going to add 7r to both sides. As we saw in the previous problem, 7r cannot be combined with 16, and it cannot be combined with pq. So I'm just going to put it kind of off to the side so I remember that when I'm doing the addition. So I'm not doing anything to the 4p term, so I'm just going to bring that down. Negative 7r and positive 7r gives me a 0. I'm not doing anything to the pq term, so I'm just going to go ahead and bring that down. I'm not doing anything to the 16, so I bring that down as well. And then I add 7r. So now I just need to get this over here. And so one way to get this over here is to undo what's happening on the right. So what's happening on the right is we have a positive PQ, so I'm going to subtract PQ from both sides. Even though both of these terms have a P in it, they are not like terms. So that's why I'm putting PQ in its own spot. Go ahead and bring down the 4P, bring down the 16, and bring down the 7R. So on the left, I have 4P minus PQ. And on the right, I have a positive PQ and a negative PQ, which gives me a 0. And then I just have 16 plus 7R. Okay, I have both of my P's over here. So what I want to do is I want to take the P out of both of these problems. And a way we could take it out of both of these is called factoring. Factoring removes the common factor within it. So when we have numbers that we're multiplying together and we want to see what's common, we factor out that common number. So I'm going to pull the p out of both terms, or I'm going to factor the p out. So p comes in front. 4p divided by p is just 4. pq divided by p is just q. And then on the right, I didn't do anything, so it's going to be 16 plus 7r. And if you wanted to check to see if this is the same, you could distribute that p back in, and you'd end up with the same expression. All right, now I have p almost by itself. It's just being multiplied by 4 minus q. So I'm going to divide both sides by 4 minus q. On the left, I'm just left with p. And on the right, I have this whole thing. So 16 plus 7r divided by 4 minus q. And that would be my answer. So let's take a look at a word problem that involves a formula. So example 3. The area of a trapezoid is this thing. A from that represents the area. H represents the height. B1 represents the length of one base. And B2 represents the length of another base. So we have a part A and we have a part B. Part A says solve for H. And we'll get to part B in a second. So I want to solve for H. So I'm going to start off with my formula. Area, as we now know it, is height times base 1 plus base 2 divided by 2. So this is what I want to solve for, this H right here. So I'm going to start off with undoing the division. So I'm going to multiply both sides by 2. 2 times A, it's just 2A. And then over here I have a 2 in the numerator, or the top, and a 2 in the denominator, or the bottom, leaving me with just H base 1 plus base 2. Okay? Almost solved for H. I just have it multiplying this. So I'm going to undo the multiplication with division. So divide both sides by base 1 plus base 2. Once I do that, on the right, I'm just going to be left with the H. And on the left, I'm going to have 2A divided by the sum of the bases. So I've solved it for H. Now let's take a look at what B wants us to do. B wants us to find the value of H if the area equals 70 feet squared, base 1 equals 22 feet, and base 2 equals 18 feet. So now I have some values for my equation. Now I can plug them in. So again, I'll write it, but I'm going to flip it this time. So I'm going to have h equals 2a divided by the sum of the bases. And this means the same thing as this. We just reflected it. So now I can plug in what I have. So h equals 2 times the area, which is 70 feet, divide by the sum of the bases. Base 1, which is, we have that value now, 22, plus 18. So I can multiply this out and add these up. So that gives me h equals 140 feet squared divided by 40 feet. So feet squared divided by feet, that's just going to leave you with feet. 140 divided by 40 is 3.5. So the height of this trapezoid is 3.5 feet. Go ahead and review through these examples for today and have a great